Hello. In this example, we're going to let f of x equal the square root of x and g of x equal to 4x plus 2. We're going to find both f composed of g of x and g composed of f of x and their resulting domains. Now, we're going to worry about the domain at the very end. So we're just going to worry about the question f composed of g of x first. Remember, f composed of g of x is f of g of x. And what that means is we work from the inside out and just replace g of x with what it is. In this case, it's 4x plus 2. Notice that I haven't done anything with f, so I still need the f of right here. So f of whatever g of x is. In this case, 4x plus 2. So that means we're going to go to the f function, and all x's are going to be replaced with this entire 4x plus 2. What that means is that we have the square root of, instead of x, we replace it with 4x plus 2. Now, you would simplify this if you could, but you can't. Yes, there's a common factor of 2, but 2's not a perfect square, and there's not a perfect square within 2 because 2's prime. So that means that f composed of g of x is the square root of 4x plus 2. Fantastic. Now then, B is asking us for g composed of f of x. Well, g composed of f of x means g of f of x. But remember, f of x is just the square root of x. So if you want to, you can write it like this. And notice that we have not done anything with the g yet, so it still needs to be here. So this is just g of the square root of x. Now notice that that means that this x and this x will be replaced by whatever is in this parentheses here. In this case, it's the square root of x. Therefore, g of the square root of x is 4 square root of x plus 2. Now notice that this radical ends for the x, and it's very obvious that this plus 2 is not underneath the radical. You have to be very clear about that. Also, by the way, do not be sarcastic, and by that I mean don't do 4 square root of x plus 2. That's just being sarcastic, and it will annoy me. So please don't do that. Now, this would be simplified if you could, but there's nothing to simplify. Therefore, that means that g composed of f of x is 4 square root of x plus 2. Now then, to find the domain. Basically, let's look at what we're looking at here. F composed of g of x is f of g of x. Now notice that we're going to first have to be within the domain of the inner function, the g of x in this case, in order to figure out what this entire g of x is. So that means that we have to have the domain of the, in this case, g, or always the second function that's listed. So for a, we have to know the domain of g. For b, we would have to know the domain of f. But also, we're going to get the range of g of x, and we have to be very careful about that. Now, sometimes it's a little bit weird to figure out what that is. So what I do, instead of going in a bit of a roundabout manner, I'm going to look at what we have for our answer. Now, first of all, on A we have f composed of g of x, and the g is just 4x plus 2, so the domain of g will be all real numbers, negative infinity to infinity. And the reason for that is because, remember, there are only two things that limit domains. The first thing that limit the domain is an even radical, such as the square root, the fourth root, the sixth root, so on and so forth. And that does that by saying that the radicand must be greater than or equal to 0. The other one, at least the only one that we've learned so far, is the rational function. Now, a rational function is anything that can be written as p divided by q. And remember that the domain is everywhere q is not equal to 0. So because g was a polynomial function, that means that it was neither an even radical nor a rational function, which means that it's going to be all real numbers. So I look at the answer that we got for f composed of g of x. That was the square root of 4x plus 2, and notice that that's an even radical. So this does limit our domain, which means that the radicand must be greater than or equal to 0. Notice that whatever's underneath the radical here will be 4x plus 2. That must be greater than or equal to 0. Then you solve this. Subtract 2 divided by 4, so x is greater than or equal to negative 1/2. Negative 2 over 4 simplifies to negative 1/2. And if you notice, that's the in domain form, or excuse me, interval notation form. Negative 1/2 to infinity like this. And then you will take the intersection between this and this, because both of these must be true at the same time. Now, if you look at A here, all real numbers is literally the entire number line, so I don't really need to shade anything because it is the number line. Now, negative 1/2 to infinity is, if I start at negative 1/2, I would shade to the right using a square bracket. Now notice that everything intersected with negative 1/2 to infinity, where are they both true at the same time? Well, that's just this stuff over here. So what that means is that your actual domain is going to be negative 1/2 to infinity. Now that's the domain for f composed of g of x. Next, we're going to look at the domain, let me get a better color here, for g composed of f of x. And notice that the f function is the second function that's listed here, so we look at the f function. And the domain here is this, well, the function is the square root of x, so the domain is going to be limited. And it's limited because it's an even radical. And remember, the radicand, x in this case, must be greater than or equal to 0. So the domain for f would be 0 to infinity. And notice that for the actual answer that we got over here, for square root of x plus 2, this also has a radical. Therefore, it can limit the domain as well. And because it has an x underneath, that means that x must be greater than or equal to 0. So notice that again, this is 0 to infinity. So if I was to do a number line, at 0 here, I would go to the right and shade the arrow. Now notice that this is 0 to infinity, and this is also 0 to infinity. Where are both of these true at the same time? Well, that's 0 to infinity. So the domain for g is 0 to infinity. One more thing that I want you to realize, f composed of g of x is not the same thing as g composed of f of x, not in general. And so because of that, there is no actual commutative property of compositions of functions. So it does matter the order in which the functions appear. Okay, so let's review what we just did. First, we found f composed of g of x, and that's just starting with the inside function, replacing it, and then taking that and replacing all x's in the second function with this function, and simplifying if you can. Same thing over here. Then the domain. We always look at the second function that's listed first. In this case, the second function that was listed was g, and g had a domain of all real numbers, so it's everything. Then we look at at the answer, the square root of 4x plus 2, we look at what, and we kind of need to put this in quotes, domain, is that we get from that. Well, there's an even radical, so it limits the domain. So 4x plus 2 must be greater than or equal to 0. Subtract 2 divided by 4, so x is greater than or equal to negative 1/2. So this is the, again, in quotes, domain that you get from the answer. So the intersection between d equals negative infinity to infinity and d equals negative 1/2 to infinity, well, that's just going to be negative 1/2 to infinity. Same thing over here. The second function that's listed, find its domain. F, well, it's a radical, so the radicand must be greater than or equal to 0. Then look at your answer. Oh, look, another radical, so the radicand must be greater than or equal to 0. And then find the intersection between these two domains. And that's going to be the domain for this function. Okay, fantastic. I know this is a lot of work, but it is important to understand, which is why we took so much time on it. Alrighty, well, have fun. I'll see you in the next video.